When looking into supplementing oxygen in an operation, the topic of oxygen purity will inevitably come up. Oxygen purity refers to the percentage of oxygen in the gas. The higher the percentage, the higher the amount. The oxygen purity standard around the world for most operations lies somewhere between 85 to 99% purity. It's important to be aware that the standards will vary between different countries and the different operation standards. For example, medical operations have a higher standard for oxygen purity, ranging between 90 and 99%. Also, consider that oxygen concentrators will produce different results in varying climates and altitudes. Knowing this, is it crucial to have the highest possible oxygen purity of 99% wherever possible? Is it even possible on a commercial or remote-scaled operation? Well, there are two answers to this question, which consider the stages of producing concentrated oxygen, as well as the costs and available technology associated with them. There could be up to 2 stages in the process of concentrating oxygen using adsorption technologies. However, when the oxygen purity required is less than 95%, using a 1-stage vacuum pressure swing adsorption or pressure swing adsorption process is enough to achieve the separation. In both pressure swing adsorption and vacuum pressure swing adsorption, a single-stage process will result in the inflow air being pressurized once, and the output will be a higher amount of concentrated oxygen. Check out our other video linked below to learn more about the oxygen concentration process using both these methods. Most of the industrial machines and processes will produce an oxygen of around 93% purity, give or take a few percent, which is otherwise known as oxygen 93 in many operations. As such, in accordance with the United States Pharmacopoeia and the European Pharmacopoeia, oxygen 93 is the standard for majority of the oxygen concentrators that use the molecular SEV process. The rest of the around 7% gas output in oxygen 93 consists of argon and nitrogen that did not get separated. Nitrogen makes up 78% of the air we breathe, and while oxygen concentrators are highly effective at removing majority of the nitrogen, a small percentage can remain, and this is expected. Argon will make up majority of the remaining percentage because argon and oxygen are similar-sized molecules, making the separation process difficult to differentiate between the molecules. Despite this, argon and nitrogen are inert gases and will not affect the overall quality of the oxygen. To be clear, it is possible to produce oxygen at 95% or higher using a single-stage, single-bed vacuum swing adsorption concentrator. However, they are not commercially available due to the high cost of zeolite, which is a necessary piece of separating nitrogen from oxygen. Single-stage concentrators use commercially available molecular sieves, which is part of the reason why most concentrators are limited to output no purer than oxygen 93. Further, assuming the machines or materials came onto the market, the cost of acquiring them would not result in a good long-term return on investment, as they would be incredibly expensive and difficult and costly to maintain if not done regularly. To produce oxygen at a higher concentration than 95% on a commercial operation, a second-stage process would be required. This would mean that a second pressurized mechanism, or vacuum swing mechanism, would be required. In second stage, the first round of concentrated oxygen will be sent through another PSA or VPSA column to further concentrate the output. Second stage concentrators typically use carbon molecular sieves or activated carbons to filter the oxygen, making them able to produce the 99% purity oxygen. However, with this high level of purity comes other problems. The oxygen recovery, or the oxygen purity going in versus the oxygen purity going out, on the second stage is low. Consider the single stage will go from around 20% purity from the air we breathe to around 93% through the one concentrating process. This results in a high oxygen recovery ratio. Second stage will concentrate from around 93 to 99% purity. Thus, a second stage concentrator is not as effective as a single stage concentrator. A second stage concentration process will also require a deeper vacuum for VSA units and a deeper pressure capability for PSA units. To accomplish this, more maintenance costs would be required for frequently used concentrators as the machines would be subject to harder work. Additionally, more energy would be required to run these machines, making capital and operational costs more expensive. Therefore, second-stage concentrators have a lower oxygen recovery and they cost significantly more to maintain. Unless the industry or application requires an oxygen percentage higher than 95%, acquiring a higher oxygen purity will typically not pay dividends. Oxygen 93 is an industry standard and is perfectly adequate to provide the necessary amount of concentrated oxygen to majority of industry applications. Industry concentrators, specifically those designed by Oxygen Solutions Inc., guarantee that the machines are outputting the highest concentrated oxygen purity for the most affordable price. Check out our website if you'd like to find out more about how our oxygen concentrators can help your operation. Thanks for watching!